Imagine you have to fetch all pages of an API using a serverless structure, but you don't know how many pages you have in total. So, how would you deal with that? You can start from the basics. First, you just make it work. Then you improve it. So you just fetch page by page, creating a process that actually works. This way, you ensure you can get all the data you need, no matter how much time it takes. And now that it's working, you can think about improving it. So, how can you make it run faster? You can probably think many different ways, but what about this one? What if, instead of focusing on data structures and confusing and complex logic, we focused on a different approach? The infrastructure controlled by the software itself. It's also confusing, probably. But imagine that if I don't know how many pages I have, I will suppose I have at least 10. So I can run my code in a container passing the instruction from the page 1 process 10 pages. This container will check the last page to verify if it's complete. If it is, it understands that probably there are more pages to be processed, and then it will start a new container using the SDK, passing the instruction from the page 11, process 10 pages, and then it will continue its process normally. This new container will run the exact same logic. So new containers will be created as needed until all pages are processed. At some point, you will probably have many containers in parallel. It may make the error tracing harder. Yeah, but the code itself stays simple, objective, and easy to maintain, and allows the process to run faster. But how much faster, you may be wondering? Well, for me, it made a 4-hour process run in under 30 minutes. The solution to a problem may not always be related to the depth of the used tools. Sometimes, using different tools in a non-conventional way may lead to surprising results. If you like this kind of subject and want to see more content like this, let's swim against the flow.